K-means clustering is a great way to get started with understanding deep learning, understanding machine learning, understanding many of the components of data science. And let's talk about this from a very simple level, how you could understand K-means clustering, and also what is the core components necessary. Like if you're going to write this yourself in Rust or Python or Julia, etc., it would be pretty straightforward, actually. It's one of the more intuitive algorithms that is a foundational component of unsupervised machine learning. So to start with, let's talk about unsupervised learning. In a nutshell, what you could think about is that you're given a big box of toys and they're all mixed up. And without anyone telling you how to sort them, you might naturally put the cars together, maybe the stuffed animals together, the blocks together. So this is essentially a way of sorting things and finding these patterns. This is similar to this unsupervised learning pattern. Now, if we look at k-means clustering specifically, what it does is it helps you find groups in data. One way to think about this in a intuitive way would be to think about a class. Let's say a student has height X, and then another student has height Y, and then maybe another student has age Z. Obviously, each student has a height, a weight, and an age, but these are the three parameters, right? We have X, Y, and Z, and you could actually use k-means to group those together in a multidimensional space. What this means is that in the case of height, weight, and age, a lot of times all three of those dimensions are going to be close to each other for different groups of people, right? Elementary kids, students, junior high students, high school students. So that's the intuition, but let's go ahead and talk about the core algorithm and how you could write it yourself very easily. There are four main steps of k-means. We have the starting point. And so what this is randomly picking, let's say, a few students as a starting point of the algorithm. Or you could use a smarter way like k-means plus plus that picks students who are different from each other. And this is the randomization, right, where you're initializing the algorithm. Maybe the intuition here is it's a little bit like picking a team captain before you play pickup basketball. Then next we have making the team. So each student would have to then join the team of the captain they're most similar to. So in the case of making this team, it would be, how close is each student to each captain? Are you the same height? Are you the same weight? Are you the same age? And then the students join the team of that closest captain. And then these are these temporary groups. Now, next in step 3, we find the new centers. So now we find the middle of each of these teams. Let's say, again, there's 4 teams or 5 teams or whatever clusters we have. We calculate the average height of everyone on team 1. We calculate the average weight of everyone on team 1. And then we calculate the average age of everyone on team 1. And then this is the average student that becomes the new center for team 1. And so this is the centroid. In this case, you would do this for every one of the teams. And then finally, in step 4, you check if you're done. So you basically go through and you keep repeating until the teams stop changing. If no one switches teams, you're done. And then if the center barely moves, you're done. But basically, you're sorting everybody by how close they are to the center of each team. And then this rearrangement of the clusters allows you to figure out who each person should be a member of. And so if we think about some of the other components here, we have the starting point. So in the case of starting with different captains, you can have different final teams. And so if you look at this, it means that you can try different starting points. You can see what groupings make the most sense, and you can find patterns that you might miss with just one try. And then also, if you plot this in a three-dimensional space, you could see like height is how far up, weight is how far right, and then maybe age is how far forward they are. And then the team group could be shown in a fourth dimension, like red, maybe blue, and maybe green. The color acts like a fourth piece of information showing which group each student belongs to. And then the computer is going to find the groups by looking at who's clustered together in the three-dimensional space. So really, in a nutshell, why would we need the experts later to then name the groups? And this is part of the intuition as well behind domain experts with unsupervised machine learning, is that while the computer can group everything together, they don't necessarily know what it means because it's not intelligent. And this is one of the problems where people are having with large language models as well, is that they're very good at the pattern matching, but then the domain expert has to come in and say, well, it might find a group of tall, heavier, older students. Who are these? Oh, maybe these are the athletes. Maybe it finds a group of shorter, lighter, younger students. Who are these people? Maybe these are the elementary school students. And then we have a group of average height, weight students. This is just the average, maybe freshman in high school. And so you need someone who's an expert to say, oh, look, maybe group one is the basketball players. Group two might be students who skipped a grade, and then group three looks like a regular student. And so the computer is going to find the pattern, but then the domain expert goes through and says the why, and then figures out how to label that particular group. So the simple math is that K-means is working to make each student as close as possible to the team center, and then the computer is trying to make this number as small as possible. And the sum of how far each student is from their team center is really going back and forth between assigning the student to the closest team and then moving the team center to the middle of the team. So really, in a nutshell, K-means clustering is a very simple algorithm. You can write it yourself in Python and Julia and R, some scripting language, and it's a great way to really start to understand the intuition behind these unsupervised machine learning algorithms, but also around multidimensional arrays, and also how to think in a multidimensional space, which is really important when you get into more advanced topics in deep learning or large language models.